Okay, so here we have the angle bisector theorem. It says that a point is equidistant from the rays of an angle if and only if the point lies on the angle bisector. So this if and only if means that we need to do it in both directions. Excuse me. Thank you. Okay. So I got to do it in both directions. So here's one direction. If a point is equidistant from the rays of an angle, then the point lies on the angle bisector. So in this case, I have something that looks like this. And the point is equidistant from these rays. So let's say this is P. Okay, and the point, again, is equidistant from these rays. What you have is something that looks like this. This length, right, whatever you want to call it, I don't know, PA, is the same as PB. And what you want to prove basically is that this ray is the angle bisector of angle BCA, okay? Okay, so to do this, it's not too bad. What do we have in this case? We have that PB is, and then we have, okay, right, that these are right angles. And then they share side PC, so we should see that in right triangle PBC is the same thing as right triangle PAC by hypotenuse leg. So I'm just going to state some things. I'm going to say since P is equidistant from rays, I know that PB is congruent to the PA. PC is congruent to itself by reflexivity. And what we could also say is that we know that this angle right here is a right angle. Oh, we know that this is a right angle. This right here and this right here. Okay, so since triangle PBC and triangle PAC are right triangles, we know by hypotenuse leg theorem that triangle PBC is congruent to triangle PAC. And then that guarantees that all their corresponding parts are congruent. So if I call this angle 1 over here and this angle 2, I know angle 1 is going to be congruent to angle 2 by CPCTC. And this implies that this means CP, ray CP, is angle bisector of angle whatever PCA, or BCA, sorry, BCA, by definition. And you're done in one direction. Now, you still have to do the other direction. So let's write the other direction. So the other direction says that if a point lies on the angle bisector then the point is equidistant from the rays of the angle. And this, to prove this, I'll just try and make some space for myself. So box that off. And I'll start writing it in this designated spot up here. So I got, in this case, I have something that looks like this. And, let me make it bigger. Okay, so in this case, I got something that looks like this. And I know that this is the angle bisector in this situation, and this is some point on the angle bisector. So let's call that point P. What I want to prove in this situation is I want to prove that the distance from here to here, which is definitely a right angle, and the distance from here to here, which is also a right angle, the shortest distance, that, you know, if I call this point A, I want to prove that PA is congruent to PB. In this situation, again, I know that this is the angle bisector. So I know that 1 is congruent to 2. And I know that this angle, let's call it 3, is congruent to 4 since they're both right angles. And then I know that if I call this point C, I know that CP is congruent to itself. So then therefore I know by angle side that this triangle is congruent to this triangle, which means that all their corresponding parts are congruent. So AP would be congruent to BP. That's the idea in this direction. So now let's go through it in more detail. Let's write it out. So now in this situation, I'm going to say that since CP is angle bisector, we have that angle 1 is congruent to angle 2. Okay, those little ones right there. Then I gotta state something a little tricky. I gotta say that since AP is the distance from P to the ray, is the distance from P to the ray, we should say AP is perpendicular to ray CA, because it's the distance, okay? Since AP is the distance, right? And what I mean by the distance is, of course, the shortest distance is the distance. Distance is the distance between P and ray CA. Likewise, we have that PB is perpendicular to CB for the same reason, right? Okay, and that's nice because then that guarantees that this gives that angle 3 is the same thing as angle 4 as both right angles. Okay, now the last thing you want to state the second to last thing you want to state is that you have CP congruent to itself by reflexive. And then the second to last thing is to say that the triangles are congruent. CAP is congruent to triangle CBP by angle, side. I demonstrated an angle, and a side. And then you have by CPCTC that AP is congruent to BP by CPCTC. CPCTC. That this will be congruent to this. And then you're done. And now you proved it in both directions. Again, make sure you see that I did it in both directions. I proved this. So this is one direction, the one I just did. You could forget about that. And then this one was the other direction, this piece. Right? It's two statements nested into one.